3DC design offers a best practice for DC and warehouse design. Traditional design isolates the engineering analyses, while 3DC runs concurrent analyses. Traditional design uses disparate systems. 3DC integrates design in one system. The speed of traditional design allows time to produce only a few biased design scenarios. 3DC takes an unbiased look at all possible design scenarios. Traditional design creates separated plans for space, labor, and equipment. 3DC integrates the three cost factors to find the best total cost solution. The traditional design approach results in the risk of not having looked at the best design, while 3DC design results in the certainty that all solutions have been evaluated. To the left, the traditional design approach might produce the expected cost of 2 layouts, while in the example on the right, 3DC produces a fully costed comparison of 5,300 layouts. The 3DC design approach analyzes the client's own inventory, demand, and workflow data. Inventory and demand data are used to generate multiple space and travel scenarios. Models are named and managed here. Total aisle length and aisle width data serve as a foundation for building layout scenarios. The range of the desired number of aisles and cross aisles will be used to generate hundreds of possible layouts. Once the scenarios are run, each aisle-cross-aisle combination displays the trade-off between travel distance and square feet. The layout area allows a graphical view of the results. This baseline facility of 144,000 square feet has a pick travel distance of 2,432 feet. Without changing the square feet, 3DC calculates that introducing ABC slotting in the facility reduces travel by 23%. The addition of a cross aisle into the slotted facility results in a total travel reduction of 36%, while adding 8,700 square feet to the footprint. Even complex facilities with multiple location sizes and aisle widths can be modeled in 3DC. Any layout can be immediately exported to CAD software for further work and for printing. Every layout produces workflow distances that need to be costed. Workflow modeling compares the total cost of current equipment to what other equipment would cost to perform the same task. Current equipment and fleet size establishes the baseline. Operational processes and material flow nodes define the work to be done and the stop and start points for workflows. Specification applies constraints to each process so that only viable equipment types will be used to compare against the baseline. For example, there might be a constraint associated with a process that only allows equipment with the capability of vertical travel. Material flows are defined based on where a process starts and stops, how much time it takes to pick or place material, how many times per day the workflow occurs, and finally, the distance associated with the workflow. The system automatically selects the equipment for a process based on the total lowest cost, including labor, depreciation, and other costs. The user can override the system and choose to cost out any other type of equipment in the library. System reports help the user make informed decisions. This report shows the total cost of current equipment and also all other viable equipment in descending order of cost savings. In the example, the user chooses to override the system solution and selects a rider pallet jack for the unloading process. Any report can be exported to Microsoft Excel. The analysis is complete. The total cost of each layout scenario can be compared to the baseline total cost. In the example, a fleet of counterbalance units can be replaced with a fleet that combines counterbalance with rider pallet jacks for a significant cost reduction. 3DC design eliminates risk, bias, and subjectivity to find the lowest cost warehouse and distribution center design.